Okay, in this result we are given with the principal curvatures k1 and k2 at a point P of the surface path sigma. Now if the principal curvatures are distinct, k1 is not equal to k2, then any two non-zero principal vectors, say t1 and t2, corresponding to k1 and k2 respectively, are perpendicular. Okay, so we are given with the principal curvatures k1 and k2 which are distinct. So corresponding to these principal curvatures, we have the principal vectors. So let us consider non-zero principal vectors corresponding to these as xi1 eta 1 and xi2 eta 2. Okay, so k1 is not equal to k2. Then by the definition of the principal curvature and the definition of the principal vectors, what do we have? We have f2 minus k1 f1 into the principal vector, that is k1 is equal to 0, and similarly for this what we have, f2 minus k2 f1 into the principal vector, that is t2 is equal to 0. So what we have, f2 into t1 is equal to k1 into f1 into t1, and f2 into t2 is equal to k2 into f1 into t2. Okay, so now let us consider T2 transpose F2 T1. Okay, I am just multiplying this by T2 transpose here. So T2 transpose F2 T1, that is equal to T2 transpose F2 into K F1 T. Okay, so that is equal to T2 transpose, I can take K here, so K in so K1, right, not K, K1, so K1 T2 transpose F1 into T1, correct? So that's equal to K1. Now what is this T2 transpose F1 T1? Okay, by our earlier result, when we consider T1 and T2, then we have T1 dot T2 is equal to T1 transpose F1 T2. The places are interchanged here. So this is equal to T2 dot T1. Okay, T2 dot T1. Similarly, if I consider this statement and multiply by T1 transpose here, so what we have, T1 transpose F2 T2, that is equal to T1 transpose K2 F1 T2, and that is equal to K2 into T1 transpose F1 T2, right? So this is equal to K2 into T1 transpose F1 T2, it is nothing but T1 dot T2. Okay, let us call these two together as the statement 1 here. Okay, now let us consider this matrix T1 transpose, right? T1 is the matrix 2 by 1 matrix here, right? So what will be the order of this matrix? It is 1 by 2 matrix. And what is the order of the matrix F2? It is the matrix LMMN, so it is 2 by 2 matrix. And what is the order of the T2 matrix? It is 2 by 1 matrix. So what will be the order of this product matrix here? It will be 1 by 1 matrix. So there is only one entry in this matrix. Okay, so this matrix must be equal to its transpose, right? So what we have, T1 transpose F2 T2, right? That is equal to its transpose. So T1 transpose F2 T2 transpose. Now what is this? It is T2 transpose F2 transpose T1 transpose transpose, right? So this is equal to T2 transpose, F2 transpose is F2 itself because it is symmetric matrix, and T1 transpose transpose is T1. Okay, so now what I got here is T1 transpose F2 T2 is equal to T2 transpose F2 T1. So this matrix T1 transpose F2 T2, this is equal to T2 transpose F2 T1. Okay, so these two are equal. So left hand sides are equal, so right hand sides must be equal from this statement. So what we have, K1 into T2 dot T1 is equal to K2 into T1 dot T2. Okay, so from this what we get, K1 into the dot product, right? I can write it as T1 dot T2, that is equal to K2 into T1 dot T2. Okay, so what we know about K1 and K2, they are not equal, right? So K1 is not equal to K2, then what can happen to this when I have this is equal to this? This must be equal to 0. Okay, so this implies that T1 dot T2 must be equal to 0. So once the dot product of these two vectors is equal to 0, how will they be? They will be perpendicular to each other. So T1 is perpendicular to T2.